Hi, Assalamualaikum and very good day to everyone. My name is Ahmad Fikri bin Abdul Maside and today I want to present about the DC motor simulation. As we can see here, this is the circuit for the shunt configuration. The circuit was connected using simulation from Proteus software. You can see at the circuit have probe meter to measuring the voltage and current in the circuit. The data and result have been recorded. From the shunt configuration, we can conclude that the motor rotates at speed 3.57 kilo RPM, which is quite fast. The input voltage and the output is same, which is 150, same as the input voltage. Since they are connected to the parallel, the armature of file windings are exposed to the same supply voltage. The input current is decreased, which is 2.3 ampere at the input and 1.0 ampere at the output. And this is the series configuration for DC motor. I have re-simulated the circuit using any electrical and electronic engineering software, which is Proteus. We can see the probe meter in the circuit to measure the voltage and current flow. All data have been recorded. This is the circuit for the series configuration. When we get the result, we can say that the motor rotation is little bit slower than the shunt configuration. The speed is 2.13 kilo RPM. The input voltage is 150 volt, while the output is 87 volt. The voltage decrease from the input because it's connected as a series. The current remains same for the input to the output, which is 0.57 ampere. That's all from me. Thank you. Let's continue to my groupmate.
So let's start with table 1. Table 1, we get motor armature voltage VA that is constantly at 203 from beginning to the end, and then we got motor armature current IA. The value is increasing by the time it went up at the end, and the motor field current IF is constantly at 0.140. And we got the motor rotation speed RPM. The speed is decreasing by the time it reached the end point, and lastly we got the motor torque Nm. The value is increasing. So this is the data that we analyze. First, the breakdown torque of the separate excited DC motor according to the graph is T breakdown is 0.5 T Nm. This is the graph that we made. We can see that it's dropping. The motor rotation speed, and next the minimum speed torque and the good approximation of the lock rotor torque of the separately excited DC motor according to the graph above is T lock rotor 1.53 T Nm. The breakdown torque and the lock rotor torque of the separately excited DC are approximately 2.5 and 2 times the nominal torque respectively. Lastly, the starting current is approximately 5 times greater than the nominal current. Next, data analysis of table 2 series DC motor. So this is the table that is been given to us to analyze, and this is the result. This is the graph that we made, the motor rotation speed versus motor torque. So the breakdown torque of the series DC motor according to the graph above is T breakdown is equal to 0.64 T Nm. The minimum speed torque and the good approximation of the locked rotor torque of the series DC motor according to the graph is T lock rotor 2.24 T Nm. So as we can see, 0.64 T is here. When it's starting to break down, the torque starting to break down, and the T lock rotor is 2.24 dN, the minimum speed, and the line current increase at 1.1 ampere when the motor speed decreases at 1307 N RPM. The starting current is approximately 3 times greater than the nominal current. Next, table 3, shunt DC motor. This is the table, and then this is the data that we analyze, that we got after we analyze the table. This is the graph that we made, the same as before, motor rotation speed versus the motor torque, and the breakdown torque of the shunt DC motor according to the graph is T breakdown is equal to 0.5 T Nm. Same as before, it's dropping at 0.53 Nm. The minimum speed torque and the good approximation of the lock rotor torque of the shunt DC motor according to the graph is 2.34 T Nm. The minimum speed torque 2.34, and the line current increase at 1.686 when the motor speed decreases at 1280 N RPM. The starting current is approximately 5 times greater than the nominal current. Lastly, the table for cumulative compound DC motor. This is the graph that we have made, the same as before, motor rotation speed versus motor torque. The breakdown torque of the shunt DC motor according to the graph is 1.73 T Nm. The minimum speed torque of the good approximation of the lock rotor torque of the shunt DC motor according to the graph is 1.92 T Nm. The line current increases at 1.192 ampere when the motor speed decreases at 1034 N RPM. The starting current is approximately 5 times greater than the nominal current. So that's all for me. Thank you very much.